A P&ID is one of the most key engineering schematics. It depicts the overall structure of the system. For example, it shows how all the pipes, valves, control systems and general operating equipment fit together and interact with one another. Since all processes are based on the P&ID, their attention to detail and correctness are of paramount importance. Any fault, even minor in the P&ID, could later result in disaster for the developed process, whether it be fatal or financially. If the P&ID is completed effectively enough, this could massively improve the efficiency and construction requirements of the process. Typically, by matching the label on the diagram with the legend, this will correlate to the type of equipment in question. Here are some common types of pump, valves and compressor in industry. A positive displacement pump, a reciprocating compressor, and a butterfly valve. The butterfly valve works by having a disc that sits in the middle of a pipe and moves 90 degrees to allow or block fluid flow completely. It can be found commonly in the food, petrochemical and chemical industries, used primarily in the transport of bulk fluids. The non-return valve only allows fluid to flow through it in one direction only. This works by having two port valves, and hence an entrance and an exit point for the fluid to enter and leave the valve. The valve requires the minimum cracking pressure in order to operate. It can be mainly found in the petrochemical industry because of its safety responses to failures in the system and ability to maintain a constant pressure. All pumps, the piston pump in particular, use basic forces of nature to move a fluid. As the moving pump part begins to move, air is pushed out of the way. The movement of air creates a partial vacuum which can be filled up by more air. This is similar to sucking on a straw. A partial vacuum is created in your mouth when you suck on the straw. The liquid is pushed up the straw because of the pressure differences between your mouth and the atmosphere. Pumps are found in many industries and have a large variety of uses, such as the transportation of fluids and also in the air conditioning system. In the piston compressor, there is a suction valve and discharge valve, both being one-way valves. The suction valve will only let air come into the cylinder and the discharge valve will only let air out. As the piston moves downward through the cylinder, air is sucked into the suction valve. When the piston moves up through the cylinder, the suction valve closes. The discharge valve won't open until a certain amount of force is applied to it. This causes the air to be trapped inside while the volume is reduced and hence increasing the pressure. When the pressure is enough to open the discharge valve, the air goes out at a higher pressure. Compressors are found in almost every industry that requires low volumes or high pressures. These include gas turbine and cabin pressurization systems. Here are some assembly videos for a non-return and butterfly valve. The cylindrical piece which is being inserted is the movable stopper used to block the flow, hence it is the fundamental part of the valve. It is spring-loaded to help keep it shut. There are three main important components to the butterfly valve: the disc, the seat and the body. The rotational disc located at the bottom of the valve is used to control the flowing material in the pipe. The disc is always in the passageway, but because it is relatively thin, it offers little resistance to flow. The seat is of paramount importance in the butterfly valve. It provides the seal between the body and the disc. The material of the seat can be made from many different polymers. This, in combination with the disc, is what makes the butterfly valve so good at accurately altering the flow rate. The body provides the overall integrity of the butterfly valve, since there are very few moving parts in direct contact with the fluid flow. This is what makes the valve so durable and easy to maintain.